All right, welcome to Unit 8, Day 2. We're going to talk about the Pythagorean Theorem, and we're actually going to expand upon that just a little bit because you guys are pretty familiar with Pythagorean Theorem, but we're going to take it a little bit further and show you how it can be used to tell us some more about different triangles. Now, make sure you copy things down as I show them to you here, but make sure if you need extra time, pause the video so you can copy these down correctly, and then you can work through the examples. Okay? So let's start off. We're going to talk about kind of why and how we use the Pythagorean Theorem and what it means. So I'm going to give you some things to write down here. Again, if you need to pause the video to get caught up at any time, go ahead. But these are the things we should have written down here. Okay, first, the Pythagorean Theorem is used to find the missing sides of a right triangle, and it must be a right triangle for this to work. Okay, and we label these sides A, B, and C, and A and B are called the legs of the right triangle. And C is the hypotenuse, which is always the longest side. It is the side that is across from the right angle. So for any right triangle, A squared plus B squared equals C squared. And so we can use this in problem solving in these examples. Okay, so I've got some examples here. If you need to copy them down, go ahead. But we're going to talk about right triangles and how Pythagorean theorem can work. If you need to pause the video at any time, go ahead. Here we're looking for the hypotenuse, x. All of these will be solving for the value x. So we just set up our Pythagorean theorem. 8 squared plus 13 squared equals x squared. Okay, I'm going to go through and solve this. We can do these separately. 64 plus 169 equals x squared. We can add these together, and we get 233 equals x squared. Now, to solve for x, we need to take the square root of both of those. And so when we take the square root of 233, x equals 15.26, approximately. Now, we are going to be rounding some of these, but remember back to last lesson, we can also write a lot of these in simplest radical form. So I want you guys to try and find the value of x in this one. That will mean you need to pause the video and try this on your own, but remember you're looking for x. Here, x is one of the legs. Okay, so you will not say x squared is equal to 7 squared plus 9 squared. You're going to put x squared plus 7 squared equal to 9 squared. Okay, your equation should look like this. I want you to go ahead and solve that for x, and when you are done, you can continue watching the video. Alright, this is what you should get. X should equal 5.66 when you do the square root of 32. Alright, let's keep going. We're going to go through those two pretty quickly, but these, starting with number 3, are going to take a little bit more work because in any of these problems that you see where the diagram itself is not a right triangle, we always want to look and see where the right triangle is. In this case, this is an isosceles triangle because we have marked congruent legs here and here, but I've drawn in this dotted line which represents what we call the height or altitude of the triangle, and that does form a right angle with the base, and in this case it divides this triangle into two congruent triangles which are both right triangles. So to find the length of that altitude or height, we can use the Pythagorean theorem still. Okay, x is going to be one leg of the triangle. The other leg just goes from here to there. Well, the entire bottom side of that triangle is 22, so from here to here you should recognize that's 11. That's half of the 22. So we're going to be plus 11 squared. And then this would be your hypotenuse, which is the same as this side on this side, which is 24. So we're going to equal to 24 squared. Now go ahead and solve that for x. Again, pause the video to give yourself time to do that. Alright, this is what you should get. X should equal 21.3. So if we set this up, I'll recover what I talked about here. X squared plus 11 squared equals 24 squared. So 11 squared is 121, and 24 squared is 576. So we subtract 121 from both sides, and we get this. And then we take the square root of both of those to get our final answer. Okay? Now, we're also going to be able to use that same kind of setup on example 4. In example 4, we have a trapezoid, an isosceles trapezoid, but the altitudes or height of the trapezoid are drawn in gray here, and that's the x that we're looking for. So once again, we're looking for the leg in a right triangle. The other leg is this measurement here, which we have to figure out. Okay, but since this is an isosceles trapezoid, and these are right angles here, these would be right angles, it makes this interior shape a rectangle, which means this is 26 from this point to this point, and these are both congruent parts. Okay, so if this is 26 and the whole thing's 40, we can do a little bit of subtraction. 40 minus 26 is 14. That means each of these is an equal half of 14, so I'm going to divide all that by 2, and we get that these are each 7. And so the triangle we're using as our right triangle has a leg that is 7, a leg marked x, and then this leg, which is congruent to this side, is 20. So your Pythagorean theorem looks like this. 7 squared plus x squared equals 20 squared. And once again, we can go through and solve that. 7 squared is 49, 20 squared is 400, so we're going to subtract 49 from both sides. So x squared equals 351. We're going to take the square root of both of those to get that x is approximately 18.7. All right? So in any of these pictures here, we can come up with right triangles to help us understand the problem. So we can use the Pythagorean theorem in problem solving. All right, now in our next example here, I didn't leave myself a lot of room, so you're going to notice that I pull out a note card to draw a diagram on. You don't have to get your own note card. Anywhere you have room on your page, you can write this out, and so don't get confused by that. But we are going to draw a diagram to help us out with this. On problem number 5, it says a roofer leaned a 16-foot ladder against a house. If the base of the ladder is 5 feet from the house, how high up the house does the ladder reach? So we're going to draw this out. We're going to, again, focus on trying to form a right triangle. Okay. We've got a diagram where we can have our ladder representing the hypotenuse of a right triangle because it's leaning against the house. The house we assume to be this vertical side. And then the ground, how far the base of the ladder is from the edge of the house, is our other leg of the triangle. And so we get a right triangle that looks like this. 16-foot ladder, not 16 foot up this way, 16 foot when you lean it to the side. This is now your hypotenuse. And we have 5 feet from the base of the house. We want to find how far up the house the ladder reaches. So we want to find this vertical distance x. Okay? So now we just set up our Pythagorean theorem, which should look like this. All right? And so when we start to simplify this, we can continue to solve. We get that x ends up being 15.2 feet. So to answer the question, the ladder reaches about 15 feet up on the house, or 15.2 is more accurate. All right, let's go ahead and keep moving on to the next part of our lesson. Okay, we're going to talk about the converse of the Pythagorean theorem. And remember, the converse of a theorem just switches the order. But we're also going to look at some other properties that help us understand some things. All right, now first I want you to understand this. This is the normal way we write the equation for the Pythagorean theorem. So if a squared plus b squared does equal c squared, then we could just switch it around using the symmetric property of equality to be c squared equals a squared plus b squared. And the only reason we do that is for these next purposes, and I'll make a note of this so you'll understand why. But we just rewrite that in this case. So if c squared does equal a squared plus b squared, then the triangle is right. It's a right triangle. But if we change this equals to another inequality, then that changes our triangle. So if we take this and c squared ends up being greater than a squared plus b squared, that means what would have been your hypotenuse, your longest side, is now longer than the sum of the squares of these two. So if we're making the hypotenuse longer, we're extending greater than 90 degrees, so we have what's called an obtuse triangle, if c squared is greater than a squared plus b squared. Okay? But if you plug in the numbers and c squared is less than a squared plus b squared, it is an acute triangle. So we can actually classify a triangle just by measuring its sides and plugging into our Pythagorean theorem to see if it equals, is greater than, or is less than. Okay? Now I want you to remember this. Always keep c squared on the left. And the reason we do that is to avoid confusion when you're classifying, because if you get something greater than the other two, greater means obtuse. And that way if you get something less than the other two, less means acute. Okay? So we're going off of whether it's greater than 90 as an obtuse or less than 90 for acute. So we can keep that matched up this way. I also want you to take a look at our instructions and our examples. Okay? There's one piece of this that we haven't covered yet, and I want to talk about that separately, so I'm going to get another note card out. Anywhere you want to make a note of this, it doesn't need to be written before all of this, but if I put it on a note card, you can put it anywhere in your notes you want. We're going to determine if three side lengths can actually form a triangle or not. And I'm going to show you what I mean, like this. All right, in order for A, B, and C to actually be lengths of a triangle, for this actually to make a triangle where C is the longest of the three sides, A plus B has to be greater than C. Notice I didn't say squared. We're not talking Pythagorean theorem here. We're just saying the relationship of the individual sides, A and B, have to add up to more than the third side, like this. Okay, if I've got sides 6, 7, and 10, they can form a triangle because 6 plus 7 is 13, which is greater than 10. And if you actually measured out sticks that were 6 inches, 7 inches, and 10 inches long, you could make a triangle. But if I used the numbers 3, 4, and 10, and I had a stick that was 3 inches, a stick that was 4 inches, a stick that was 10 inches, I cannot make a triangle. If I line up the 3 on this side, the 4 on this side, and anywhere I try and rotate that, they're not going to meet. Even if they did meet exactly in the middle, if it was 3, 4, and 7, 3 plus 4 equals 7, it's still not going to make a triangle because it's not greater than 10. In this case, it's less than 10. So this is not a triangle, this is. And so as we go through our examples here, we want to see if in fact it does form a triangle. If not, we can just say no triangle. But if it does form a triangle, we should be able to classify it using this criteria. So we're going to try these. First, 3 plus 7 is 10. 10 is greater than 9. Okay, so this is a triangle. So now we're going to check the longest side as C. So we're going to do 9 squared, and we're going to check 3 squared plus 7 squared. 9 squared is 81. 3 squared is 9. 7 squared is 49. 9 plus 49 is 58. And 81 is greater than 58. Since C squared is greater than A squared plus B squared, it is an obtuse triangle. So these would be sides of an obtuse triangle. Okay, I want you to try number 7. Okay, first check and see if it is a triangle. See if the two smaller ones add up to more than the third one, and it does. And then classify it based on these criteria. Okay, 20 plus 21 is 41, which is greater than 29, so this is a triangle. And then since 29 is the longest side, it gets plugged in for C squared into our formulas up here. 29 squared is 841. The other two squared, 400 and 441, add up to 841 also. Since C squared equals A squared plus B squared, it is a right triangle. Okay, here's what I would like you to do. Our video is just about done. We're about out of time. I want you guys to do 8 and 9 and bring your answers to class. Okay? You guys got to do this one on your own.